Good morning. Welcome to the Structural Vulnerability Warding Off the Three Uglies: Flood, Earthquake, and Fire. I'm Tom Hughes, the Commonwealth of Pennsylvania State Hazard Mitigation Officer. This speakers will incorporate structural techniques and information to mitigate the impacts of flood, earthquake, wildfires, and fire. The panel will discuss good and bad practices, what works and what doesn't, based on their experiences, vulnerabilities and how to adapt to the current risk, and also gearing towards future risks. As able, we're going to identify and will highlight regulations, guidance, and building codes that apply. They have incorporated solutions, information, resources, and possible funding streams for each. And this may also be discussed during the Q&A session. I also ask them to think about, and ask you to think about, your critical primary and alternate sites used for the continuity of operations and during the time when your business recovery plans are executed. We want to make sure that you can actually rely on them when you actually need them. The presenters to the left of me are as follows. For the first speaker will be Randy Beam with the Corps. He'll be discussing the flood topics. Randy Beam is the Chief of Flood Risk and Floodplain Management Section for the U.S. Army Corps of Engineers Omaha District, where he leads a team of engineers totally dedicated to identifying and reducing flood risk, formulating non-structural mitigation measures, and supporting sound floodplain management. Mr. Beam has been in position since July 2001. He's the chairman of the Corps' National Non-Structural Floodproofing Committee. The committee consists of 10 members and technical advisors who advocate a complete set of non-structural tools and techniques for reducing flood damages across the country. Mr. Beam, as I said, was with the Omaha District. He's the Flood Risk Manager and Silver Jackets Coordinator. He provides oversight for 6 active Silver Jackets teams within the district. He's a hydraulic design engineer and a project manager and has been employed with the Omaha District for 28 years. Our second presenter will be Mike Tong with FEMA. Mike is a physical scientist at the National Earthquake Hazard Reduction Program, Building Science Branch of the Risk Reduction Division under FEMA's Federal Insurance and Mitigation Administration. He's responsible for the various FEMA NEHRP projects to develop technical guidance, resources, and tools, including update of NEHRP recommended seismic provisions. He joined FEMA in 2007. Prior to working at FEMA, he was senior research scientist at the Multidisciplinary Center for Earthquake Engineering Research at the University of Buffalo. He has also received his PhD and MS degrees from the University of Buffalo. Our third speaker will be Clark Woodward. He will talk about wildfire issues. Clark Woodward is the founder of and CEO of Red Zone Software, a developer of disaster response software tools for public safety, insurance, and risk management markets. Red Zone provides insurers and public utilities with natural disaster tracking, automated exposure analysis, notification on a geospatial policy management platform. Since 2001, Clark has been involved with a wide variety of mitigation and response programs across the country, including completion of more than 100,000 home assessments, wildland urban interface firefighter training, and homeowner education programs. He has an extensive operating experience in the public safety industry as a GIS specialist for the Rocky Mountain Incident Management Team, was a former officer on the 4 Mile Fire Department in Boulder. Clark holds a bachelor's degree in geography from the University of Colorado and lives here. He's a local boy here in Boulder, Colorado. All right, we're going to do things a little different here. I do have cards, but they're color-coded. All right, Joel, can you, have you passed them out, Joel?
Yeah, everyone's got them on the edge of the table there.
Okay, the cards are as follows. What I'm looking for is, we have blue that will be for flood, pink that will be for fire, and yellow for earthquake. So it'll make it a little easier when we try to go through the Q&A session. Please write legibly. I work in the Emergency Operations Center. I can usually read stuff, but make it a little easy on me, all right? The ground rules will be that we will write down potential questions and we'll try to answer them during the session. I'm going to use the easel here for any parking lot questions. We might have some real technical questions that I might have to put on the board here that we can't answer today. Those questions might lead to a future session, webinar follow-up after this workshop. I want to make sure that we capture all your questions, that you guys came here, that you get things answered appropriately. All right, how did the team come up with this session? I mentioned I'm the State Hazard Mitigation Officer for Commonwealth of PA. I deal with protection of 12.8 million folks there in our state, in our Commonwealth. I've been with the agency for 21 years, and as you know, I get a lot of these questions that come in that are going to be presented today that hopefully they'll cover these categories. And when I was asking the board here for NHMA, and also my FEMA Region 3 counterparts, they also are getting these questions. So we thought structural vulnerability is really something that really needs to be addressed, and be talked about more than it is. We've had NHMA come through also. They scared the heck out of me when they did their legal aspects for hazard mitigators. And so, when Ed came twice to our state, I felt very uncomfortable, but I think, with some of the things they're going to talk about, we're going to be getting to where we need to be as far as information that we receive and actually go out to the public and actually to our sister agencies. With that, I'm going to start with Randy Noah being from the Corps, talking about the flood risk.
Thank you, Tom. Good morning. Tom, that was a good question. How did he come up with this session? Because it helps to be thorough and complete. Because when I had first seen or heard from Tom about the subject matter, warding off the 3 uglies, I looked at my 2 co-presenters and I looked in the mirror myself. I thought we looked pretty handsome. So then I realized, no, we're talking about 3 other items here. Hopefully, what I'm showing here, red fire, blue water, earth, and brown, that matches up with the color code on the cards there that you passed out. I'm going to talk a little about flooding. If you're in the last session that was in this room, I thought it was fantastic to hear from these communities on what they're doing for resiliency. And what's interesting is that if you look, is this starting to become the new norm, the normal within our country anymore? We've had suffered through Hurricane Sandy. We had the Colorado flooding in 2013, Hurricane Katrina, Missouri River flooding in 2011. And we're seeing damages in the range of $38 to $54 billion annually from 2006 to 2013. But even more amazing, from 1985 through 2013, we're seeing about $10 billion annually in damages across the country in flood damages. I always look at flooding, and I think part of the process is get out there, identify the flood risk, communicate the flood risk, and then try to do something to prevent damages or mitigate damages that are occurring. And during 2011, I was out during the flooding on the Missouri River, and I feel like we kind of missed the mark when it came to communication. This top left photo here is a little community of Modale, Iowa, that's located right along the left bank of the Missouri River, and they just kind of gave up on their flood response, an active flood response. And what they did was someone painted a staff gauge along the side of the doorway for their local bar and grill in 1-foot increments, and they were trying to determine how deep was the floodwaters going to get right down Main Street in the community. The one thing you can't see is that they had a lottery there for $1 a person. You could write your name next to the foot increment, and then they had a lottery on it. Fortunately, the community did not flood. We were able to all work together through the state, the community, the counties, everyone, with responding actively during this flood event, and they didn't get wet at all. But it's a concern to me that we're not communicating the risk real well, or how we can go about mitigating those risks. Another thing I saw, which is kind of difficult for where you're sitting maybe, was a residential structure with a little breezeway and a two-door garage here, 2-car garage. And to prepare for the flood, they went to the local hardware store and they purchased plastic, and it's about 8 foot wide, and they stretched that entirely around their home. And they connected the seams with duct tape, and they stretched this plastic across the end of the house over to the garage. There's no support. They even enclosed the downspouts, so if there was a rainfall event, the water coming down the downspouts was going to be trapped within this plastic. So again, I feel like we kind of missed the mark when it comes to communicating to the public on what flood risk is and how do you prevent from getting damages. Grand Forks, North Dakota, on the Red River to the north, and you know, it always comes to mind to me when we talk about the consequences associated with flooding. You know, you get the damages to property, the emergency costs associated with it, business losses, the social effects, and the health costs. And I don't think we do a real good job of really accounting for the health cost when it comes to flooding across this country. But that one, and maybe many of you remember that, because they got hit with flooding, they got hit with a blizzard. The blizzard caused gas lines to break, and then they had a fire break out in their downtown area, so they also burned during this major flood event. When we, within the Corps of Engineers, look at flood risk right now, we look at the probability of flooding and the consequences. And the probability is what you can do, or you know, what's the frequency of flooding in a particular area. And you can reduce the frequency of flooding if you look at like a levee or a dam. You know, you can change how frequent you'll see flooding occur in a certain location. And the consequences, or what are the damageable areas, or you know, or attributes that could be damaged during a flood event. We could be looking at structures. Are they critical facilities? Are they residential, commercial, public, and industrial? We could look at the land use, agricultural, urban, public, and we can also look at the infrastructure, highways, roads, rails, utilities. And if we can reduce the consequences, we can also reduce flood damages. And I wanted to make note here, critical facilities, if they're in your flooding inundation area and they become inoperable during a flood event, the area of impact extends well beyond that flood inundation area. So when you look at a flood map and say, well, if we have a 100-year flood and this is the outline for it, that the effects are going to go well beyond that. Because if you have a hospital, a fire station, EMS services, or so forth located in there and they become inoperable, just think of the additional population size outside of that flood area that will be impacted. And when we talk about risk, you know, what is risk? You know, and generally, you know, you can look it up on Google it or something, and it'll say the possibility of suffering harm or loss, and it's the uncertainty of the probability of occurrence. And I was out in Annapolis, Maryland, recently doing an assessment out there. And I saw some wooden telephone poles or power poles here. They had transformers on it. They had electrical, telephone, all kinds of cables running on these things. Well, what got me, I looked down at the bottom of the poles, and this is how they were supported. One was down into the ground, and the other one was just shimmed up on a piece of wood. And these things stretched block after block. And can you imagine, you know, what kind of risk is this for this community? That if high winds came up and this were to fail, what kind of behavior, you know, are we facing there, you know, and what's going to happen as a result of this type of behavior? Critical facilities, like I said, I think it's very important. Some of you may recognize this fire station. It's located in the Thomas area out near Sacramento. And what I like about this is critical fire station, critical facility. It's built a two-story facility. All the communications equipment and everything they have in racks, and it's on the second floor. The fire trucks themselves are on the main level, but everything is accessed through the upper level. So during a flood event, their equipment here would stay dry. They'd have to remove the fire trucks, and it's located down here. It's off by itself, and then across the street from it is all kinds of housing that's being developed. And what bothered me about this is that while the facility itself is 2 stories high above the 100-year water surface elevation right now, the homes were all below that. They were 1-story homes built slab on grade, no basement. And when I stood up here looking out across these homes, there was no hatchway or anything into the attics. And isn't that a problem that we ran into in New Orleans during Hurricane Katrina? That when people can't evacuate or don't evacuate during a flood event, is that while flood water comes up, you're going to try to seek safety within your house. Well, these people are going to end up crawling into their attics, and then once inside their attics again, if this area were to flood, what are they going to do to try to seek safety once they're in there? And it just seems to me, preparedness would say, look at some type of a hatch on your rooftop and so forth. Another interesting thing, I was talking to the fire captain there, and he says, well, once the Corps of Engineers comes in and certifies all these new levees that we plan to build, we're going to go ahead and reduce the height of this. We're going to put our fire station back at ground level. And does that really make sense when you have a critical facility like that that has to service so much of the population? 2011, the flood on the Missouri River another critical facility. This is a nuclear power plant that's located about 12 miles upstream from Omaha, Nebraska. That flood was a little bit different, where we have 6 main stem dams on the upper Missouri River. But up in Montana and Wyoming, they had so much rainfall in the month of May occurred during a 2-week period. It was more than what they normally see in over a year's worth of precipitation. So we were trying to meter that water down the Missouri River, and what was odd about this flood event, it was coming through all these dams, but it's still exceeding the capacity of the Missouri River. Major flood event there. And this shot here is showing the river itself right at capacity level near this nuclear power plant, and they had not prepared previously to really fight a major flood like this. They didn't think with the 6 dams you'd see anything like this occur. Around the building you see a black stripe here, or strip. It's an 8-foot rubber bladder that was to be water filled, and they had talked with us back and forth as regulations and requirements would be, and they said, hey, Corps of Engineers, go ahead and release whatever water you need to release out of your dams. We can handle it. We've got this bladder that's going to be 8 foot high. What they couldn't handle was the employee that was on a skid loader and backed into the bladder when it was filled with water, ruptured it, and the whole thing deflated. It occurred right when we were having peak discharges for the flood event come out of our dams, and eventually they ended up flooding the lower level of their facility, but luckily nothing got into the reactor plant itself. Since then, the Nuclear Regulatory Commission says, we can't have anything like this occur, so we're looking at all of our facilities across the country that are located on rivers, and they're looking at 10,000-year level of protection, which is very, very good, because last thing we want to have is an event like that that could occur. Things that are very important are land use zoning, I believe, building codes, regulatory permits, and non-structural mitigation. I worked on levees a lot during my career, but I really feel when it comes one-on-one with communities and people that we ought to really be looking at some of these other tools like this for the preventive and mitigation measures. If any of you ever drive through the Omaha, Nebraska area on Interstate 80, if you look to the south of the interstate, you're going to see a large earthen embankment. Back in 1905, Union Pacific, which is headquartered in Omaha, this is before there was any regulations in the floodplain or anything like that, they had a large wooden trussel that they were constructing and everything. Well, they came through and they dumped dirt, and this whole thing now is just it's a earth-covered embankment here that crosses a 700 square mile watershed. And if you can imagine what that did for flooding in the community of Omaha as they started to develop that back in the 1900s, and hopefully, we wouldn't see anything like that occur. And I would think if we had better land use zoning or building codes and permitting actions, that we wouldn't see anything like that occur. When I look at non-structural measures, I'm looking at physical and non-physical measures. When I talk about physical, I'm going to get into that a little bit more. It's where we actually do something with the structure itself, whether it be elevated or relocated. When I'm talking non-physical measures, these are more along the lines of floodplain mapping, the zoning, the building codes, and things like that. But when you look at these non-structural measures, to me, they adapt to the characteristics of the flood. So when you do something non-structurally, you're actually not changing or affecting the floodplain, the flood stages, the velocities of the flood, or hopefully even the environment. And if you adapt these things appropriately, most of the time they're compliant with the National Flood Insurance Program. When I'm talking physical measures, I'm talking about acquisition or buyout, relocation, elevation of structures. We do dry flood-proof, preventing water from going in, wet flood-proof, small berms and flood walls. In areas that have basements where maybe the basements are getting damaged, we'd even look at maybe removing the basement and adding a utility addition alongside the house. For non-physical measures, like I said, we're looking at mapping, evacuation plans, operational changes, maybe if there's a number of dams or other facilities located in the floodplain, looking at land use and even flood insurance. These are things that you're not going out physically changing a structure. You're preparing information that can be used to help prevent damages in future flood events. I like this slide here I've seen for resiliency, kind of this systemic approach to resiliency where You have the ocean off to the right side here, and you have groins and beach restoration, you have tidal marshes and forest, and you have shoreline stabilization, and you have flood walls, and then back on the dry side, you have structures, and if they're at a high risk, you can look at acquiring those structures, you can elevate other ones, maybe you need to relocate structures from a lower elevation to a higher one, and we also incorporate flood warning. I think this is great. I think this is the approach the United States needs to take. Unfortunately, I feel within the Corps of Engineers, if I roll into town with a study team, I can look at individual structures and maybe a warning system and say, well, what's the feasibility of us getting involved here? Or I can look separately at a berm or a levee, but there's probably very low probability that I'm going to be able to look at a combination of a levee and doing something back behind her. Our economics force us to go with the highest net benefit plan, so we're either going to find something like a levee, or without the levee, we would look at doing something to the structures behind it. But I truly feel in our country, to get a handle on our future flood risk, we need to be doing a combination of everything within this coastal area, and finding a way to get around the hurdles with economics is going to be take some further study or actions, I think. When we're assessing the situation, we're looking at the flood characteristics. What's the depth of flooding? What's the velocity? What's the duration? What's the rate of rise? Is there debris or ice? We're looking at site characteristics. Where are structures located? What's the soil type, topography, the parcel size? Is it urban or rural? When it comes to the structures themselves, what type of construction? Is it wood? Is it concrete? What's the foundation? Then there's other considerations. We're taking this all in when we're looking at assessing an area and its flood risk. Here's a few slides of just typical measures that we do. The top three are for elevation on extended foundation walls. Top left is before it was elevated. Top right shows the final product. The lower one is dry flood proofing. There was a Pizza Hut, as you can see, that was in a shallow water flood hazard area. They put a water resilient material on the face of the building, and they came back in with a brick laminar over the front of that, and that prevents flooding up to about a depth of 3 feet. Relocation works very well. Here we have a 2-story house, a wraparound porch, attached 2-car garage. It was moved out of this floodplain. It sits now up on a high bluff overlooking the river and the floodplain that it used to sit in. For acquisition, sometimes you'll see the homes can be auctioned off, moved out of there. Other times you see that they're demolished just to open up that floodplain. It's interesting, if you get a chance out in the Federal Triangle, you'll see where there's been a lot of things occurring in the capital area there with the Metro Subway. I always thought where these air shafts are for the Metro Subway, I thought that was for tourists like me that got tired of walking. You just sat down on those and rested your feet for a little bit. Then I realized they're actually were placed in there at a height like that to prevent water from coming into the shafts. That's a permanent measure. Down here you can see it's a non-permanent measure, and someone here has already kicked a few of the sandbags away. That's got to be a concern. Or over at the Robert F. Kennedy Justice Department, they've got a flower pot, which is probably for more of a terrorist activity, but at the threat of flooding, they also put some sandbags in there. There's doors, National Archive, they put in some doors. They test them periodically to see that they're keeping water out of the facility. I also feel that we talk a lot about repetitive loss, and we talk when it comes to structures, residential structures and so forth around the country. Even though I reside in Nebraska, we have a number of repetitive loss structures in the state of Nebraska. But when you look at flooding and with our system of levees across this country, it occurs to me that some of our infrastructure is also reoccurring repetitive loss. And after the 2011 flood event, this graph here shows it's the Missouri River flowing down between Iowa and Nebraska. We had significant damage occurring on some of our levee system, which is shown in the solid black line here. And generally what we do is go out and we make repairs. When after that flood event, we spent hundreds of thousands of dollars repairing levees that were overtopped or eroded and so forth. And I went back and looked at a history of some of these levees. We had seen since 1952, there's a number of times that these same levee systems had been damaged, but we go in and we would just do the same thing. You know, let's don't think about doing anything different. Let's just repair them at whatever the expense is and move on. Well, this time we had an opportunity, and with working with landowners, and it was actually at a landowner's request that we were able to look through this. We were able to set back about 11 miles of federal levee systems away from the Missouri River. This was completed in early spring of 2012, and by summertime they had a significant rainfall water runoff event in this area that probably would have damaged those levees had they been on the same alignment that they were when they were constructed back in the 1940s. But since we were able to move this levee back a little bit, we had lower stages, we had lower velocities, we didn't have those recurring damages that we had seen after the 2011 event. So I definitely believe if we're going to talk about repetitive losses, we need to talk about repetitive losses to infrastructure, bridges, dams, and levees. This is, we have a website for our Corps of Engineers National Non-Structural Floodproofing Committee. The web address is at the bottom here, or you can just Google NFPC, National Non-Structural Floodproofing Committee, and that'll bring you to the site, and we have all kinds of technical resources, publications, and information that we think would be helpful. Another thing that we've done in recent years is entered into a three-party agreement with the Association of State Floodplain Managers and FM approvals, where we're looking at and testing temporary flood barriers and trying to get those certified. So out of our Engineering Research and Design Center located in Vicksburg, Mississippi, we'll go in and water test different barriers that are used and set up prior to a flood event to prevent floodwaters from entering a structure or an area. And if they pass these standards, they become certified. And there's a, off of our website, or if you go to ASFPM's website, you'll see the logo here in the upper left corner. That'll take you to the page that has these products that have been certified. And what I like about this, if we don't have a certification program and your community is facing an impending flood event, you're going to find people out there that are going to say, hey, we can help you. Instead of putting millions of sandbags down, we got this nifty product that will just lay out in a matter of minutes, and we're going to prevent your community from flooding. Well, how do you know how well that product's going to work if it hasn't been tested and if it hasn't been certified? So I truly believe in this program here that for the Corps of Engineers, I would hate to be on the spot in front of the mayor or the city council or something and have them say, Randy, we have these manufacturers on site, what products should we use? Because I feel like there's some liability associated with that. But through this program, we can go to a list of products that have been tested and then look at where these products would fit. We've had a tremendous number of products that have been tested that were not certified. Doesn't mean they're not good products, but what has happened is that these manufacturers have gone back to the drawing board and they're redesigning these products to come back in for testing again to see if they can become certified. This is a matrix. This is too hard to read from where you're sitting out there, but this is just a product that we have up on our website that talks about how to reduce flooding. Again, it looks at the characteristics, the flood event, site location, the structures, and so forth. And as you step across answering these questions, across the top here, it has a number of non-structural techniques, and eventually it will lead you into an assessment that guides you towards, well, this technique type will work, this technique type will not work. And it's just a handy matrix tool, but like I say, it's also up on our website. We bring everything together, just like if you're going to study for a dam or a levee, you're going to want to bring the hydrology, the hydraulics, and the damage information all together. And we do that when we assess these structures individually, and we're trying to determine the estimated annual damages on every structure that we're looking at. So there's science behind what we're doing with the non-structural measures. A lot of times people think, well, there's so much design that goes into a levee or a dam, we don't have that in a non-structural. Well, we do. We're following building codes, zoning, all kinds of requirements, and everything that we do non-structurally can stand up against the flood events that they're designed for. One of the last things that I wanted to leave you with, that I've been looking at, and this is a series of somewhere between 20 and 30 structures that we did an assessment on, and we looked at, for some of these, row by row, you look at a flood wall, elevate the structure, maybe it's a buyout, once again, elevating the main floor, removing the basement. When we come across, with our economics, we have to look at the cost for that plan on an individual basis, and we have to annualize those costs, and we also annualize the benefits, where your benefits have to be greater than the cost. So when we subtract that out, and then we also do the benefits divided by the cost, we come up with a benefit cost ratio. Well, the three that I'm showing here in the red have benefit cost ratios below 1, and they also have negative net benefits. It means it's a poor investment for the federal government to go in there and put $1 into just putting a flood wall around this, I think it was a commercial building. The ones that are highlighted in yellow are marginal. They have benefit cost ratios that are 1.4, 1.5, and the net benefits are on the plus side. But if you look down in the green, we're getting benefit cost ratios that are 2.5 to 1, 3 to 1. We're getting almost $15,000 in net benefits, $8,000. A lot of times people see a chart like this in a neighborhood, and they'll say, for all these homes, why don't we go in and cherry pick out these the ones in green? Those are your most feasible. And I always say, stop and look at it differently. Maybe because of topographic or geographical conditions, maybe because of cultural conditions, this entire neighborhood is significant. And what I suggest that you do is that you total up all your net benefits or your cost and benefits and see what you do. Well, when I totaled this up for all these structures, we have positive net benefits, and then we had a very positive benefit cost ratio of 1.7 to 1. So instead of cherry picking just a few in the green out of here, if we look at it totally, comprehensively for the entire area that we're trying to assess, it appears to be feasible. So I'm always trying to tell communities, because how would you feel if a federal agency rolled into your neighborhood and said, well, we're just going to take a half dozen of these structures and mitigate those, and the rest of you that are marginal or doesn't look like we should invest in you, even though you do have some flood risk, we're going to walk away from you. So I think really to keep neighborhoods intact and communities intact, try to look at it comprehensively to see what you can come up with that way. We have a number of programs on our website. We have fact sheets for the Corps of Engineers. Some of you probably have dealt with this. Some of our programs look at, they're just studies. Some provide 100% federal funding. Some you have to cost share, 50% federal funding matched with 50% funding for yourselves. Then we have programs that can lead into implementation and construction, whether it's a levee or whether it's non-structural projects that we can implement. They cost share the studies 50-50, and when it comes to project implementation, the federal government generally provides 65% of the cost and 35% comes from the sponsor. The only difference between a general investigation and a continuing authorities is that the general investigation studies are for projects that exceed like $15 million, and continuing authorities are less than $15 million in size. With that, we'll hold our questions till the end.
Right, say that. We're going to hold our questions to the end. I also neglected, there is a handout that Randy provided. It's the natural flood risk adaptive measures. And on the flip side, we added website developed by the PA Silver Jackets team before, during, and after a flood, which you may find helpful. Joe, I believe, put them on the back table there for you. Next speaker will be Mike Tom.
So you heard about the first ugly, and this is the second Uglies. So we're going to talk a little bit about what we're going to do to ward it off. I'd like first to start to let you take a look at the picture here. And this is a photo that was taken a moment after a magnitude 6.3 earthquake hit Christchurch, New Zealand, on February 22nd, 2011. And you can almost feel the kind of a destructive power of the earthquake. And just less than 20 seconds, that earthquake destroyed almost a big, prosperous part of the city. But this earthquake is not a major big earthquake, 6.3 magnitude. It's actually an aftershock of an event that had occurred just a couple of months before. And that event is magnitude 7.1, but it didn't generate that much of the damage than this one. So what happened here is that this earthquake that occurred is so close to the center of the city, it's only 6 miles, and the fault rupture is so shallow, it's only 3 miles deep. So I'd like to ask these questions so you have some kind of considerations in your mind. Should this kind of an earthquake occur near your community, are the buildings in your community be able to resist the kind of the ground shaking? And then what kind of things that we can do to reduce the risk before an earthquake like this hit? Let's look at the earthquake hazard and the building vulnerability in our country here. This is a map of earthquake hazard. It's currently used by the International Residential Building Code. The color codes here corresponds to the 5 seismic design categories that's used across all the building codes and design standards. The color code red and orange represent the high seismic hazard. The yellow color represent the moderate hazard, and the light blue and the white color represent the low hazard. So I gave you some statistics. 46 counties out of the 27 states and territories have high seismic hazard. And then in there, 75 million people live there, and also 24 million housing units are exposed to a high hazard. Annualized earthquake loss is estimated per hazard as $5.3 billion. Now, if these statistics is not alerting enough, just give you one example. Northridge earthquake occurred 20 years ago. That still stands as the second most costly natural disaster in the U.S. When Tom asked us, who's going to go first in this session, I suggest that Randy should go first. Because this is a very interesting comparison. The Northridge earthquake is the second costliest earthquake. Anybody knows which one is the first one? It's Katrina. So you can see that earthquake risk and the vulnerability of our buildings is there, it's real. But it's just that earthquake is not happening that often, and therefore that sometimes people do forget about it. For this particular earthquake, that cost us $76 billion, 449,000 buildings, homes damaged or destroyed, and along with that is 9,000 commercial buildings, and also cost of 57 casualties. So I'd like to talk a little bit about some of the considerations for seismic retrofitting, along with some of the vulnerabilities. A little bit different than the great presentation that we have heard or learned from the previous session, that many of those people that presented from a top-down approach. The considerations that we're going to touch on here is kind of bottom-up. So this is not exhaustive, and I'm sure that you will be able to come up with other considerations and thoughts. Those are all valuable, so we can probably discuss later. So I'm going to talk a little bit about the local seismic hazard, building codes, building stock inventory, and then followed with that, we'll talk a little bit about prioritization by seismically hazardous, construction types, and then building weaknesses. And this slide shows the hazard curves of 10 cities across the country. The horizontal axis that measures the intensity of the event, and the vertical axis measures the frequency of the events will occur. So obviously, the higher intensity of the event, the less frequent it will occur. But there are a couple of things I'd like to point out here. First, you see these curves seems to be very close. No, actually, they're actually way apart. That's only because the scales that we're using here, for example, and vertically, they are log scales. So they kind of combine these things, push them closer. But actually, they're magnitudes apart. Now, look at the vertical line there. You see the two red circles. What that's suggesting here is, in the West U.S., an earthquake typically will occur 1 in 10 years. Whereas that in Central U.S. and also Central and East U.S., the damaging earthquakes probably occur on average to 1 in 100 years or maybe even more. Now, if you look at the circle on the bottom there, oops. That shows the largest possible ground shaking in the relevant cities. And you can see that both the West Coast and the Central area, they seem to have the same level of the largest shaking events and the return period of frequency. These things will not happen that frequently. The return periods is probably 10,000 years, but they're highly uncertain. We don't have any technology nowadays to predict when it's going to happen, what year it will happen, what months, or day, or where exactly that's going to happen. But it's just a risk that we cannot ignore. So, just a couple of thoughts on how to consider these local seismic hazards in consideration of seismic retrofitting policies. Generally, in the Central and East U.S., you should have more time between the damaging earthquakes to allow the state and local communities to address the risk from existing buildings. So that will give you a little bit leeway there. But for all hazards, high hazard areas, the impact of the potential very large earthquakes, that should not be underestimated. For that, we should consider to target essential and seismically vulnerable buildings. I'll get back to that just a little bit later. I'd like to talk a little bit about the building codes for seismic risk mitigation. Typically, the building's seismic performance is related to a lot of things. Material, construction, design, and then also the earthquake event that hits the building. These things are all included in the building codes. So it's specifically required as to how you will follow the codes to do a design and construction. The new buildings that's currently built comply the current IBC and IRC, they should be expected to have much better performance than those old buildings constructed before 1970s. Buildings that are built between the 70s and now, they're generally are called code-compliant constructions if they are benchmarked against the ASC 31. Basically what it means is that these buildings should have sufficient life safety in there based on the building codes then. But there are buildings that's built before 1970s. Those are buildings outside of the benchmark codes. And they are the ones that may have inadequate life safety protection. And those are the things that we should seriously consider for seismic retrofit. And I'd also like to mention that for retrofitting, the current standards and codes will allow the retrofitting to take 75% of the seismic capacity that is used for new buildings. So what it means is that even though buildings are retrofitted, their strengths and the capacity may not be as good as new buildings. Code adoption and enforcement. So one requirement for the existing building seismic retrofitting policy should probably be to adopt and enforce suitable building codes for new buildings and allow the triggered code upgrades. This will prevent the new buildings to become the vulnerable buildings in the future. As for the existing building retrofit, the existing building should use the IEBC or ASC 4113, which is the newest existing building retrofit guidance and standard. Insurance Service Organization has a building code effectiveness rating schedule, and that is a measurement of how well the local communities adopt and enforce the building codes. So communities would like to follow on how the building codes are used and enforced, are encouraged to consider to join the BSAC system. Currently, 63% of those jurisdictions that join the BSACs, they adopt both IBC and IRC and have a decent enforcement program. Next, I would like to talk about the evaluation and the inventory of existing buildings. I don't know how many people here ever participated in any seismic screening or building inventory project? Is there anybody? Well, it is very important, and it's probably the first step for communities to start thinking about seismic retrofit program by looking at what kind of buildings they have there, how many of those seismically hazardous buildings are there in the community. FEMA published FEMA recently updated a guidance document called the FEMA P154, Rapid Visual Screening of Buildings for Potential Seismic Hazards. And we also developed a mobile software that will help the communities to implement this procedure to quickly identify those most hazardous buildings and inventory those buildings. We also provide some trainings and guidance and technical support for communities that will be interested in using these procedures and inventory their seismic hazardous buildings. Finally, I'd like to talk about the prioritization of the seismic retrofitting. So, like all the mitigation projects or programs, funding is not always there, and even if it's there available, that's very limited. And therefore, how to target these limited fundings to make the best use of it, it's always a challenge question. First, you should consider the critical facilities, such as the hospitals, the schools, EOCs, and hazmat facilities. And those are the buildings or facilities that should be considered as the highest priorities for seismic retrofitting policies or program. But more hazardous constructions and greater risk and greater needs for seismic retrofitting programs should be also considered. Listed here, there are 6 building types, and some of them are seismically hazardous, others have some very serious weaknesses. So I'm going to go over the URM buildings, the non-ductile concrete buildings, and also talk a little bit about the wood frame residential constructions, and then follow with that, I'd like to also talk about non-structural retrofitting. As Wendy mentioned there, that retrofitting of non-structurals is not just for earthquake but also flood. You will find that that's very important. It's the best bang for the buck. The URM buildings, the unreinforced masonry buildings is known as the most seismically hazardous building type. And this type of construction is considered as the collapse hazard in earthquakes. The commonly seen the failure mode of this kind of building is the outward plane failure of the wall, and resulting in the loss of the floor support and the collapse of the floor that could trigger the whole building fall onto the ground. The URM buildings are no longer permitted in high seismic areas in the U.S. FEMA has a guidance document, 774, that helps the communities to establish seismic retrofitting programs for URM buildings. You may wonder, so how many URM buildings are still out there? NESAC, the Northeast State Emergency Consortium, recently conducted a project to assess how many URM buildings are there. they found that based on hazards, there are 1.6 million URM buildings in northeast area. But that's an underestimate. And they compare their LiDAR inventory results, and it suggests that this estimate is probably 15% underestimated. Nationwide, we have about 17 million URM buildings still existing. The picture here that shows where these URM buildings are located. You can see the light color on the west side of the country. That suggests that we have less and less URM buildings in the west coast because there are retrofit programs that's taking out of these dangerous URM buildings. California law also requires the localities to establish seismic retrofit programs for URM buildings. You probably heard about the Napa earthquake that occurred last year. That caused quite some of the damage in the local building stocks, in particular the URM buildings. Napa passed the ordinance to retrofit URM buildings in 2006 and mandated that 3 years those URM buildings should be retrofitted. Most of those are actually retrofitted, and some of them didn't. And this earthquake is a test. 70% of those unretrofitted URM buildings that see the structural damage and get red tagged as considered unsafe. Whereas the retrofitted URM buildings, 20% of those get tagged as structurally unsafe. So there's a major improvement in there. Bear in mind that URM buildings to begin with, it's not a good building for the earthquake. The typical kind of retrofit for URM buildings are you tie the walls to another lateral load resistance systems, such as shown here in the first picture, or you brace the parapets with the steel braces, or you tie together the building, the walls, to increase its lateral load resistance capacity. The next seismically hazardous building type is a non-ductile reinforced concrete buildings. These are the frames or wall buildings constructed before 1975. The non-ductile concrete building collapse was first learned in 1971 San Fernando earthquake. And since then we have seen these kind of building collapse in major earthquakes again and again. Shown here on the top of the picture is the Oliver View Hospital that was constructed just shortly before the San Fernando earthquake hit the area, and it heavily damaged that building, almost collapsed. The two lower pictures, those are the non-ductile concrete buildings collapsed in the Christchurch earthquake. Along with that, took many of the fatalities. The first one is the CTV building, and the second one is the Penview building. You can see how bad those buildings collapsed. Retrofit of the non-ductile concrete buildings typically will require to put a second lateral load resistance systems. As shown here, the steel frame systems is put in and tied with the existing building. One of the challenges with the non-ductile concrete buildings is not all these non-ductile concrete buildings are seismically hazardous. So how do you determine which one is the most hazardous ones? Currently, FEMA is working with the structural engineering community to develop a procedure that will help to identify which are the ones that's mostly dangerous. Finally, I'd like to talk a little bit about the light frame residential structures. The light frame residential structures are the most of the building stocks in the country. They generally perform very well in earthquakes. However, they do have some weaknesses. Two of the commonly seen weaknesses are the brick chimneys and the cripple walls. It can be fixed, but it will need some effort. Here are some pictures of the chimney fall off from the Napa earthquake. On the top right corner there, you see the fireplace wall fall off. And this is a story that's been well known in the community that a certain year boy is having a sleepover at home, and the wall fall on him. Luckily, he survived, but the risk of brick walls, especially brick fireplace walls, is real there. Cripple walls is another weakness. Here are some of the pictures of the cripple wall damage of the buildings from the knockout earthquake. California State Code requires and provides some seismic retrofit criteria for fixing the cripple walls for the earthquake, but the criterion only applies for cripple walls up to 4 feet. In Napa, there are some cripple walls that are higher than 4 feet and due to floodplain requirements. And currently, there's no guidance as to how you retrofit the cripple walls above 4 feet. Napa Earthquake Recovery Advisory issued 2 advisories. The first one is for the chimney. Basically, it recommends to replace the masonry chimney with a lightweight metal flue or abandon the unit completely. Previously, it recommended the bracing of the chimneys on the roof. It's no longer recommended because it's not practical. The second advisory is regarding to the cripple walls. The advisory includes a plan set, which includes the design drawings, and will lead the contractor to strengthen the cripple walls, and that can be used as a plan to submit to the local building department. And shown here is a picture of a plywood that's sheathing the cripple walls, and this particular building survived from the Napa earthquake. I'd finally like to mention about the non-structural retrofitting. Non-structural damage accounts for most of the earthquake damage, and it can result in a big loss of the use of the building. There are many non-structural components. Architectural building components, such as parapets, canopies, mechanical, electrical components, plumbing components, HVAC systems, and fire sprinkler systems, furniture, fixtures, and equipments. Typically, non-structural risks could include life safety, property loss, and the functional loss. So whenever you consider a seismic retrofit program, non-structural retrofitting is always a part of the program. We have a design guidance, FEMA E74, and this guidance includes 70 different non-structural components. It provides the technical specifications, risk rating forms, and sample inventory checklist. This document can be downloaded from the website, and we also have some training materials available for people who want to learn about the details here. So, in conclusion, existing buildings are a risk that needs to be addressed by mitigation policymakers and professionals, and seismic retrofitting policies that do need to be based on the local seismic hazard and risk, and adopting the building codes, enforcing the building codes for the new buildings, and the code-triggered upgrades should be required as prerequisite for seismic retrofitting policies. Retrofitting policies and programs should also encourage screening and inventory of seismic hazardous buildings. And finally, prioritization of the seismic retrofit should target the critical facilities, hazardous buildings in the communities, and then don't forget about the non-structural components. With that, I guess the question will be.
Thanks, Mike.